Okay, and welcome back. We are on our last section of Chapter 8. The first part of our chapter we have spent working with explicit rules. These explicit rules are the ones we've been working with, which are right up here. Arithmetic is a sub n equals a sub 1 plus n minus 1 times, that should be d, not k. And geometric was a sub n equals a sub 1 times r to the n minus 1. Remembering that when we write these rules, we have a value for, with arithmetic, we have a value for d and a value for a sub 1. And with geometric, we have a value for a sub 1 and a value for r. Now we're going to be looking at how we can write recursive rules, which basically means that in order to figure out the next term in the sequence, you need to know the previous term and then have a ratio or a common difference that you use. Our rules are up here. We have for arithmetic, for a recursive rule, for an arithmetic sequence, we would have a sub n up here equals a sub n minus 1. That means you take the previous term, the term a sub n minus 1 is the term before a sub n, and you just add your common difference to it, and that'll give you your next term. The geometric series, you are looking at a sub n equals your ratio, your common ratio, times a sub n minus 1, which basically means you take your term right before the one that you want, multiply it by your ratio, and you get your next term. Whenever you're writing a recursive rule, you need to make sure that you define what a sub 1 is and then write the rule. So just to start with here, something pretty simple. It wants us to write the first 6 terms of the sequence. And in order to do that, we look at our rule. When we know the first term in the sequence is 1, and then from there, our difference is 4, plus 4, which means we're adding 4 each time to our sequence. So we'd have 1 plus 4 is 5, plus 5, or excuse me, plus 4 is 9, plus 4 is 13, plus 4 is 17, plus 4 is 21. There's our first 6 terms. And just be careful because the first term is not always 1. A sub 1 might be a different number. And then our second example here, a sub 1 equals 1. So our first term is 1. And then it says we are subtracting 3 each time. So 1 minus 3 is negative 2, minus 3 is negative 5, minus 3 is negative 8, minus 3 is negative 11, minus 3 is negative 14, and we could keep going on and on and on. So how the recursive rule works is basically in order to get any term in particular, you look at the term right before it, a sub n minus 1, that's the one right before it, and in this case you subtract 3. So it wants us to actually practice writing a recursive rule, and first thing we need to know is which rule we're going to write. Is it arithmetic or is it geometric? Well, in this case, our d, we are adding 10 each time, so this is arithmetic, so we're going to use that rule for an arithmetic sequence. First thing we do is define our first term, a sub 1. Well, in this case, a sub 1 is 3 because you can look at the sequence and tell. A sub n is just going to be a sub n minus 1. So you're going to take the term previous to it and add the difference. And we're just going to add 10. This a sub 1 and a sub n minus 1 are part of your formula. The only thing that you're going to replace with the number is your d value. Okay. This one, if we're deciding if it's arithmetic or geometric, this is geometric. To figure out our ratio, we take a term and the one previous to it, 40 over 16. That simplifies to 5 halves. So our r value is 5 halves. So when we go to write our answer, we first define what's our first term. That's 16. And a sub n is going to be our r value, which is 5 halves, times a sub n minus 1. What that means is you take your term previous to it, multiply it times 5 halves, that will get you the next term. Again, these are just very similar to what you've just been doing. Okay, I give you a sequence and you just need to write the rule. So on this first one here, 2, 14, 98, it's geometric. Okay, r equals 7 because it's times 7 each time. You have to define what your first term is, which is 2, and then write your rule, a sub n equals 7 times a sub n minus 1. Next one, it's arithmetic because it's going down by 6 each time. So you're going to define a sub 1 is 19. And your rule, a sub n, okay, remember our rule, is going to be a sub n minus 1. Well, and we're subtracting 6 each time, so it'd be minus 6. Okay, this slide is just listing out our rules again, our explicit rules and our recursive rules, just your formulas that you use to plug in. Okay, so now we are going to go from one form to the next. So this, we are going to go from explicit to recursive. Okay, in order to do that, the two things we need to know is what our first term is and what our common difference is. Okay, very common mistake is that people think that their first term is -6. It is not -6. It is our a sub 1. Our first term is when the value of n is 1. So we'll get to that in just a second. And anytime we have an explicit rule, our coefficient of n is our common difference. So in this case, our common difference is 8. And our a sub 1, our first term in the sequence, is when n equals 1. So it'd be -6 plus 8 times 1, which is 2. So when you go to write your recursive rule, first things first, we define a sub 1 equals 2, and then our a sub n is, we take a sub n minus 1, and we add 8. Okay, this one is an explicit rule for a geometric sequence. So we're starting in explicit, and we are going to recursive. So the first thing we need to remember is if we have an explicit rule, -3 is our a sub 1. The coefficient is always our first term, and what's being raised to the power of the base is our r value. And with geometric, it's a little bit easier to write these rules. So we'd have a sub 1. We always have to define that as -3. And our rule is going to be a sub n equals r, which is 1/2, times a sub n minus 1. Okay, here in our next one, we are going to get started. We start with a recursive, and we are writing an explicit. Okay, so if we're going to write an explicit, we need to know what our common difference is, and we need to know what our first term is. Okay, so if we look, it defines our first term as -1. So a sub 1, or excuse me, is -5. And our common difference, remember, is that number that's added or subtracted on the end, which is -2. If we're going to write an explicit rule, we don't have to define a sub 1 because that's part of our rule. A sub n equals a sub 1, which is -5, plus n minus 1 times d, which is -2. When we did these earlier, we distributed the -2 and combined our like terms, but it's okay, we'll leave it like this for right now. Okay, this is a geometric sequence. We start recursive, and we are going to explicit. Okay, so we need to know our a sub 1, and we need to know what our d value is. Again, nice thing about recursive rules, we need to know what a sub 1 is. It tells us that's 10. And d, remember, is just that coefficient, which is 2. So if we are going to write our explicit rule, we'd have a sub n equals a sub 1, which is 10, times 2 to the n minus 1. Remember, in an explicit rule, we have our exponent that says to the n minus 1. Okay, now I'm starting explicit, and I am asking you to write a recursive rule. So if we have an arithmetic and we need to write a recursive rule, we need to know what our d is. Remember, d is just our coefficient of n, so that's -4. And a sub 1 is not 17. Remember, our a sub 1 is not that first constant there. Our a sub 1 is what we get when we substitute 1 in for n. -4 times 1. So our first term is 13. So if we are going to write our recursive rule, we define a sub 1, we said was 13, and our rule a sub n equals a sub n minus 1. Oops, n, that's an n. And our difference is 4. Okay, moving on to the next one. We are given an explicit rule here, and it's asked for a recursive rule, and it's geometric. So we know that our a sub 1 is 16. If we go to write our rule, a sub n equals our ratio, which is 3 times a sub n minus 1. So that one was nice and easy. And we just got one more example here, or one more in each. It says to write an explicit rule. So we're starting in recursive and we are ending up at explicit. So I need to have a sub n. Okay, so let's define a couple things first. So we know our first term is negative 12. We know our common difference is 16. So when we go to write our rule, we just plug those numbers in. A sub n is negative 12 plus n minus 1. That's always part of our rule, times 16. Again, if you want to distribute the 16 and combine your like terms, that's fine. Down here on the bottom, we have a recursive geometric, and we need to write an explicit. So we just need to say a sub n, just making sure we know what we have here. Our a sub 1 is 2. Our common ratio is negative 6. So if we're going to write our rule, we'd have 2 times negative 6 to the n minus 1. Hope you have a great day.